Welcome back to Mr. Vaughn's classroom. Please take a moment, hit subscribe, give this video a thumbs up, and let's get started. Unit 4 on functions. This is lesson 14, absolute value functions, part 2. Our learning goal today is to investigate distance as a function. We have 3 learning targets today, so as we go through the practice problems, please keep these at the front of your mind. If at the end of the lesson you don't understand any of these, please drop a comment below and I'll get back to you with any clarification you might need. Learning target number 1, I can describe the effects of adding a number to the expression that defines an absolute value function. Learning target number 2, I can explain the meaning of absolute value function in terms of distance. And learning target number 3, when given an absolute value function in words or in function notation, I can make sense of it and can create a table of values and a graph to represent it. Our glossary terms start with absolute value. The absolute value of a number is its distance from 0 on the number line. This simply means we don't care whether it's above or below, so we don't have positive or negative. We only care about the distance. Therefore, whether it's 5 above or whether it's 5 below, the absolute value is going to be 5. Our next glossary term is domain. The domain of a function is the set of all its possible input values. Remember, the domain consists of what numbers you are allowed to have for your input, typically your x value. So you need to think about things like, does it need to be positive or can it be negative? Does it need to be a whole number or can it be partial numbers? Is the x on the bottom of a fraction? Is the x under the radical symbol? These are things you need to think about to determine what values of x would be allowed in that certain situation. Our next glossary term is piecewise function. A piecewise function is a function defined using different expressions for different intervals in its domain. What we're talking about here is that we have different rules to follow depending on what that value is for the input. So having an input of 1 might follow one rule to find y, but an input value of 10 might follow a different rule to find the value of y. That's a piecewise function. Our next glossary term is range, and range is the opposite of domain. The range of a function is the set of all its possible output values. So think about the specific situation you're talking about. Do your numbers have to be positive, or can you have negative outputs? Do your outputs need to be whole numbers, or can they be partial numbers? Do your output numbers need to be a multiple of something, or can they be any number in between? These are the things you want to think about when you're coming up with what your range could be. Now we can start on the practice problems for Unit 4, Lesson 14, Absolute Value Functions. The absolute value function can be defined using piecewise notation. That's what we see to the right. Use this notation to find the following values. So to make this really clear, what I want to do is write out what each of these rules says. Then I'm going to highlight them to color code them, and then I will highlight each of the problems 1 through 6 with the color that matches the rule they follow, and then I will give the actual values. So this top rule says if x is greater than or equal to 0, then y equals x. The bottom rule says if x is less than 0, then y equals negative x. So first, I'll take this top rule and I'll highlight it in yellow. And now we're looking for any x values that are 0 or greater than 0. And I'm going to highlight them in yellow. So that means number 1, number 2, number 4, then looking at 5 and 6, I'll come back to those. So for 1, 2, and 4, remember that it said in these cases y would equal x. So if y equals x for number 1, then it equals 10. If y equals x in number 2, then it equals 0. And if y equals x in number 4, then it equals 3.14159. That's an abbreviated version of pi. Next, we had the category where we said that if x was less than 0, then y equaled negative x. So that would match up with number 3 here. In that case, if y equals negative x and negative 3 is positive 3. Now we need to look at 5 and 6, because what they've done is they've given us y, and we have to figure out what the x was. So on number 5, we have two choices. If y equals 7, then there's two options. Either x was 7, and it followed the top rule, and it came out to 7, or that 7 is really negative 7, in which case it would follow the bottom. So if y equals 7, then x equals positive 7 or negative 7. Because both of these would have given us an answer of 7. To make this clear, let me show here. If I said that x was 7, then 7 equals 7. If I said that x was negative 7, then negative 7 would also equal 7. So it could really be either one of these. And now, if we look at number 6, if y equals negative 5, then we have to think about this. If we tried positive 5, then it would follow the top rule, and 5 would be greater than or equal to 0, and y would be 5. That doesn't work. If we tried negative 5, then negative 5 is less than 0, and it follows the bottom rule, but then negative 5 is positive 5, so that doesn't work either. So in this instance, then there's no answer. And if you want to understand this better, look at the other answers we have. In number 1, the answer was 10. That's positive. In number 2, it was 0. In number 3, the answer was 3. That's positive. In number 4, our answer was positive. In number 5, our answer was positive. And in number 5, we showed whether x was positive or negative, we still get a positive answer. So the reason that 6 has no answer is because it doesn't matter whether you put a positive number in for x, a negative number in for x, or 0 in for x, there's no possible way to get a negative number in for y. If you have any questions about this practice problem, please drop a comment below, and I'll get back to you with any clarification I can offer. Our next practice problem. Here are 4 equations of absolute value functions and 3 coordinate pairs. Each coordinate pair represents the vertex of the graph of an absolute value function. Match the equation of each function with the coordinates of the vertex of its graph. The vertex coordinates of the graph of one equation are not shown. So what I want you to notice here is that we have vertexes of negative 9, 0, 9, 0, and 0, negative 9. If you were to take the x and plug it in, you would get the y. When you see these vertical symbols like this, that means absolute value. And that means whatever is on the inside becomes positive. So, if I were to take this negative 9 and try it in A, then negative 9 minus 9 would become negative 18, and that negative 18 would become positive 18. So that doesn't match. If I take this negative 9 and I put it into b, then that negative 9 becomes positive 9, and 9 plus 9 is 18. So that doesn't match. If I take that negative 9 and put it into c, negative 9 plus 9 becomes 0, and the absolute value of 0 is 0. So this becomes absolute value of negative 9 plus 9, which equals the absolute value of 0, which equals 0, and that means C matches number 1. Next, we have a 9, a positive 9. If I put it into A, then 9 minus 9 becomes 0. The absolute value of 0 is 0, and that is the Y for number 2. Therefore, A matches number 2. And finally, we have a 0 for x. So if we put 0 into b, we have the absolute value of 0, which is 0, and 0 plus 9 becomes 9. That is not what we have in number 3. So when we take this 0 and we put it into d, then the absolute value of 0 is 0, and 0 minus 9 becomes negative 9, which is what we have in number 3. Therefore, D matches number 3, and B is the one that does not have a matching answer. If you have any questions about this practice problem, please drop a comment below, and I'll get back to you with any clarification. All right, our next practice problem says function g is defined by the equation g of x equals the absolute value of x. Function r is defined by the equation r of x equals the absolute value of x plus 2. Describe how the graph of the function r relates to the graph of g, or sketch the graphs of the two functions to show their relationship. So I'll say a couple of things on this one. First off, we notice that r is simply g plus 2. So r of x is g of x plus 2. This means the y values for r of x will be bigger than the y values for g of x. The graph of r of x will be the V shape of g of x shifted up by 2. And let me show you what I mean. First, I'll make a table where I have x and I have g of x. So if x is 0, then g of x is 0. If x is negative 1, then g of x is 1. If x is positive 1, g of x is positive 1. If x is negative 2, g of x is 2. If x is positive 2, then g of x is also positive 2. Now, if we do the same thing with x and r of x, when x is 0, r of x will be 0 plus 2, which is 2. When x is negative 1, the absolute value of negative 1 is 1, plus 2 is 3. When x is 1, absolute value of 1 is 1, plus 2 is also 3. When x is negative 2, the absolute value of negative 2 is 2, plus 2 is 4. And if x is 2, the absolute value of 2 is 2, plus 2 is 4. So as you can see, the graph of x just takes the values of g of x and makes them 2 larger for the y value. So you're still going to have that same V-shaped graph, but g of x will have the point at the origin, and r of x will shift that v up by 2, and its point or its vertex will be on the y-axis at y equals 2. If you have any questions about this practice problem, please drop a comment below, and I'll get back to you with any clarification you might need. Our last practice problem. Here is the graph of a function. Select the equation for the function represented by the graph. Now, what we have on this practice problem is a great opportunity to show all 4 of the shifts of an absolute value function. So I want to use this problem to take that opportunity to show you just that. So the first thing that you need to understand is a general absolute value function. And this is simply f of x equals the absolute value of x. So when that happens, if x is 0, the absolute value of 0 is 0. If x is 1, the absolute value of 1 is 1. If x is negative 1, the absolute value of negative 1 is 1. If x is 2, the absolute value of 2 is 2. If x is negative 2, the absolute value of negative 2 is positive 2. So the general absolute value function is a V-shaped graph with its vertex at the origin. So now let's see what happens in all of the other examples. If we look at A, When x is 0, the absolute value of 0 is 0, minus 5 is negative 5. When x is 1, the absolute value of 1 is 1, minus 5 is negative 4. When x is negative 1, the absolute value of negative 1 is 1, minus 5 is negative 4. So you can see when we subtract 5 outside the absolute value function, this shifts down 5 units. And this actually ends up being our answer. But I want to take this opportunity to show you what the others look like. So let's look at B. If x is 0, the absolute value of 0 is 0, plus 5 is 5. If x is 1, the absolute value of 1 is 1, plus 5 is 6. And if x is negative 1, the absolute value of negative 1 is 1, plus 5 is 6. So when we add 5 outside the absolute value symbol, what we do is we shift the v up 5. So we know that B was not the answer. Now let's look at C. If x is 0, then 0 minus 5 is negative 5, and the absolute value of negative 5 is positive 5. So this shifts up. When x is 1, 1 minus 5 is negative 4, and the absolute value of negative 4 is positive 4. If x were negative 1, negative 1 minus 5 is negative 6, and the absolute value of negative 6 is positive 6. If x were negative 2, negative 2 minus 5 is negative 7, and the absolute value of negative 7 is positive 7. So that leads us off of this coordinate plane. Let's go in the opposite direction. If x were 2, 2 minus 5 is negative 3, and the absolute value of negative 3 is positive 3. I'm going to skip forward to 5. 5 minus 5 is 0, and the absolute value of 0 is 0. And if x were 6, then 6 minus 5 is 1, and the absolute value of 1 is 1. So notice now we still have our V shape, but now when we subtracted 5 inside the absolute value function, we actually shift right 5 units. So C was not the correct one. And then the last one is D. Let's try -6 for x. -6 plus 5 is -1, and the absolute value of -1 is 1. If x was -5, then -5 plus 5 is 0, and the absolute value of 0 is 0. If x were -4, then -4 plus 5 is 1, and the absolute value of 1 is 1. Now we have our V shape, but our V shape has now shifted to the left by 5. So it wasn't D. So the correct answer is A, but what I want you to notice is that if we subtract outside the absolute value symbols, we shift down that many units from the origin. If we add outside the absolute value symbol, we shift up that many units from the origin. If we subtract inside the absolute value symbols, we shift right that many units from the origin. And if we add inside the absolute value symbols, we shift to the left that many units from the origin. So make sure you start to learn these, because it'll make graphing in future lessons that much easier. If you have questions about any of the practice problems we've done, please drop a comment below and I'll get back to you with any clarification I can offer you. To finish up, remember that the learning targets were: number 1, I can describe the effects of adding a number to the expression that defines an absolute value function. So, do you understand that adding outside the absolute value symbols moves it up? Do you understand that subtracting outside the absolute value symbols moves it down? Do you understand that adding inside the absolute value symbols moves it to the left? And do you understand that subtracting inside the absolute value symbols moves it to the right? Learning target number 2. I can explain the meaning of absolute value function in terms of distance. Meaning, can you explain to somebody that an absolute value function is telling you how far something is from 0 without worrying whether that is in the positive direction or the negative direction? You're only worrying about the distance, therefore your result is positive. And learning target number 3, when given an absolute value function in words or in function notation, I can make sense of it and create a table of values and a graph to represent it. So are you able to take and create a table of values by picking values of x and then seeing what values of y you get and filling those into a table? Or are you able to take values of x, calculate your values of y, and then plot those on a graph? If you feel comfortable making all three of these statements, then you're exactly where you should be. If you have a question about any of these three learning targets, please drop a comment below and I'll get back to you with any clarification I can offer. If you found this video helpful, please hit the subscribe button and give this video a thumbs up. I look forward to seeing you in the next lesson.